problem number 31, we're given the information for the reaction SO2 gas plus NO2 gas is equal to SO3 gas plus NO gas. The equilibrium constant is 18 at 1,200 degrees Celsius. If 1 mole of SO2 and 2 moles of NO2 are placed in a 20-liter container, what concentration of SO3 will be present at equilibrium? So in order to go ahead and find this equation, we can go ahead and break it down into 1 mole divided by 20 liters is equal to 0.05 molarity. 2 divided by 2 moles divided by 20 liters is equal to 0.1 moles molarity. From this, we can go ahead and simplify this even further using an ice. The equation would go ahead and be the 2 SO2 plus NO that we are going to go ahead and be using on this ice table. So it's 0.05, 0.1, 0, and 0. We know it's going to be negative x minus x plus x plus x. So we have 0.05 minus x, 0.1 minus x, x, and x. So from this, we go ahead and find the equation SO3 times NO divided by SO2 times NO2. So from the information given above, we know that the 18 is another number that we need to go ahead and incorporate, and it is then plugged in to equal 18 is equal to x times x divided by 0.05 minus x times 0.1 minus x. From that, we can go ahead and simplify this equation into 18 times 0.05 minus x times 0.1 minus x is equal to x squared. From this, we can go ahead and simplify it even further into 18 times 0.005 minus 0.15 x plus x squared is equal to x. From this, we go ahead and find 0.09 minus 2.7x plus 18x squared is equal to x squared. We then want to go ahead and get rid of the x squared on this side, so then we do minus 1x squared, so then we get 17x squared is equal to 0. From this, we go ahead and plug it into the quadratic equation, and once that is done, we go ahead and find out that x is equal to 0.04 0.7598. But we go ahead and need to divide this number by 0.1, and we get 0.48. And 0.48 is our final answer. For number 37, we're given the problem at 25 degrees Celsius, the equilibrium constant Kp for the reaction PCl5 gas is equal to PCl3 gas plus Cl2 gas is 0.18180. Sufficient PCl5 is put into reaction vessel to give an initial pressure of 2.74 atm at 200 degrees Celsius. Calculate the pressure of PCl5 after the system has reached equilibrium. So from this equation, we can go ahead and use an ice chart. And from the ice chart, we go ahead and see 1.80 is equal to x squared divided by 2.74 minus x. So we can go ahead and simplify this even further to 4.93 minus 1.80. X is equal to x squared. And we can simplify this even further to go ahead and reach our quadratic equation. .93, and all of this is equal to 0. From this, we are able to see that x is equal to 1.49. We then subtract 1.49 from 2.74 that was given in the equation. And that gives us 1.25. And that is our final answer. For number 42, we are given the information 4H3PO4 Ka1 is equal to 7.3 times 10 to the negative third. Ka2 is equal to 6.2 times 10 to the negative 6. And K3 is equal to 4.8 times 10 to the negative 13. An aqueous solution of Na3PO4 therefore would be. So from this equation, we know that NO3PO4 aqueous solution will dissociate to form PO4 with a 3 negative charge. This would raise the concentration of PO4 ions in the solution, putting the pH of the solution above the third pKa in accordance with the Henderson-Hasselbalch equation. This would mean the equation is basic. So from this information, we go ahead and know that the equation is basic. And that is our final answer. For number 43, we're given the information. The pH of the tomato juice is 4.5. Calculate the concentration of the hydrogen ions in this juice. So from this equation, the only information we are given is 4.5, which is the pH. So we know 4.5 is equal to negative log of H positive. We also know that the pH this is where that equation comes from. So in order to go ahead and reverse this, we would do 10 to the negative 4.5 is equal to H positive. And if we go ahead and plug that into a calculator, we get 3.2 times 10 to the negative 5 is equal to H plus. And that gives us our final answer.